Okay students, now let's do the next question. Okay, here the question is, for the network shown below, assume that the initial conditions are 0. Okay, so here fortunately they have already said that the initial conditions are 0, which means you don't have to now find the value of the initial current across the inductor or the initial voltage across the capacitor, because in both the case they have already said that the initial conditions are 0. So there is no need of considering the steady state condition of the circuit. Okay, so all you have to do is simply apply the Laplace transform to the circuit and then find the answer. That's all. Okay, so in that case we all know that this the Laplace transform of a resistor is a resistor itself, the Laplace transform of an inductor is Ls, and the Laplace transform of a capacitor is 1 by Cs, right? So therefore for t greater than 0 comma, the transformed circuit is given as, so let's draw the circuit. So here the switch is closed, right? After t, for t greater than 0 or after t is equal to 0, the switch is closed, right? And look over here, we have a signal over here, sine t, right? It's a voltage source over here. So let's say this is our voltage source whose value is given by V of s. The switch is closed at time t is equal to 0. Then you have a resistor whose Laplace transform resistor is 2 itself. The Laplace transform inductor is Ls, and the value of L is 1. So you have 1s, or it is nothing but just s itself. Okay, s. And you have a capacitor over here. Capacitor is 1 by Cs. 1 by Cs means 1 by 0.5 s, right? We have over here 1 by 0.5 s. Okay, what is 1 by 0.5? 1 by 0.5 is actually 2, right? 2. So this is nothing but 2 by s. So the impedance of the capacitor is 2 by s. The impedance of the inductor is s, and the impedance of the resistor is 2 itself. Okay, and I of s is the Laplace transform of I of t. So the question is to find I of t, right? So that means we need to find the value of I of s, and then after that we need to find the inverse Laplace transform using partial fraction. Okay, so let's do this question. So applying or writing the mesh equation of this equation, right? The Kirchhoff's voltage law of this equation, I of s into 2 plus s plus 2 by s, okay, is equal to V of s. This is the Kirchhoff's voltage law equation, right? And here this can also be written as I of s into, let me see, 2s plus s square plus 2 by s is equal to V of s. Or in other words, I of s is equal to V of s into s by, this can be written as s square plus 2s plus 2. Okay, this is the equation. Now next is to substitute the value of V of s. Okay, and according to your question, the value of V of t is actually sine t, right? So if this is V of t is equal to sine t, then what is the value of V of s? V of s is nothing but the Laplace transform of sine t, and the Laplace transform of sine t is, we know that the Laplace transform of sine omega t, the Laplace transform of sine omega t is omega by s square plus omega square. So therefore the Laplace transform of sine t is omega, the value of omega is 1. So you have 1 by s square plus 1. This is the Laplace transform. This is the value of V of s. This is the Laplace transform of V of t. So which means you need to substitute this over here. So you will get, therefore I of s is equal to 1 into s is s. So you have s by s square plus 1 into s square plus 2s plus 2. Okay, this is how we write. We can't factorize this, we can't factorize this, which means we need to, that means these two itself are the factors themselves. That means these two are the factors themselves. Okay, means you can't factorize this and you can't factorize this. Both the equations are not factorizable. Okay, so now if you want to find the value of I of t, the value of I of t is equal to the Laplace inverse of s by s square plus 1 into s square plus 2s plus 2. Okay, this is the Laplace inverse. So which means you need to find the inverse of this, and to find the inverse of this means you need to partially factorize this, which means you need to first change this into s by s square plus 1 into s square plus 2s plus 2. Okay, so how do you factorize this? You see over here, this is the degree of s is s square. Always the degree of the coefficient, right? The degree of the numerator must be 1 minus the degree of the denominator. So here it is s square plus 1, right? If it is s square plus 1, then the numerator should be as plus b, where a and b are the coefficients you need to find. Plus, and the other factor is what? S square plus 2s plus 2. So here also the degree is 2, which means the degree of the numerator should be 1. The degree of s and the numerator should be 1. If you have already used a and b, so the other letter I'm going to use is c and d. So it will be cs plus d. So we need to find the value of a, the value of b, the value of c, and the value of d. That's what you need to find. And there is no any easy method. So all you have to do is you go for the straightforward technique, that is by finding the LCM. So by or by cross multiplying. So therefore in that case s will be equal to, s is equal to, you will have cross multiplying each other to find the LCM. You have as plus b into s square plus 2s plus 2 plus the other one is cs plus d into s square plus 1. Okay, and then after that you compare these two equations. That's what we do. So here let me first expand this whole thing. Okay, so this will become let me see, this will become as cube, write it, as cube plus 2as plus as cube plus 2as square plus 2as plus bs square plus 2bs plus 2b plus cs cube plus cs plus ds square plus ds square plus d. This is the expanded version. Okay, 1 2 3 4 5 6, correct, and here also 1 2 3 4, correct. Okay, so now what I'm going to do is I'm going to group everything in terms of s. Okay, because this is written only in terms of s, so I'm going to group everything in terms of s. That's the basic procedure. So first I will write the coefficients of s cube. What is the coefficients of s cube? You have an s cube over here, so that is a, and you have another s cube anywhere? Yes, you have a s cube over here, so the coefficient of this is c. So therefore the coefficient of s cube is a plus c. Now what is the coefficient of s square? The coefficient of s square is, here you have 2a, okay, and here also the coefficient of s square is b, so you have plus b, and you have the coefficient over here as d, so it will be plus d. So these are the coefficients of s square. Plus, next is the coefficient of s, and the coefficient of s over here is, you have 2a over here, then you have 2b over here, then you have c over here, right? You have a c over here. There. This is the coefficient of s. Okay, and what about the coefficient of s raised to 0? The coefficient of s raised to 0, that is, look for the terms without any s. There you have one over here, 2b, right? 2b, and is there any other term? Yes, d plus d. Okay, 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. Yes, okay, so I haven't missed anything. Okay, so this is the value So therefore S is equal to this equation, right? So what is the in this side? Okay, let's talk about the LHS over here. What is the coefficient of S cube in LHS? There is no S cube over here, right? There is no S cube over here. If there is no S cube over here, which means that the coefficient of S cube over here is 0. The coefficient of S cube over here is 0. 0 into S cube is 0, right? So there is no S cube, which means the coefficient of S cube is 0. And the coefficient of S cube over here on this side of the equation, the coefficient of S cube is A plus C, which means A plus C is equal to 0, okay? Likewise, there is no S square over here, which means the coefficient of S square is 0. And here the coefficient of S square is 2A plus B plus D, which means 2A plus B plus D is equal to 0. Okay, here there's S over here, and this is 1 into S, right? So this is the coefficient of S over here is 1, and the coefficient of S over here is 2A plus 2B plus C, which means 2A plus 2B plus C is equal to 1. Okay, and here the coefficient of S raised to 0, right? The term without S, the coefficient of S raised to 0 is 0. So therefore this term is also equal to 0, which means 2B plus D is equal to 0. Okay, 4 unknown variables, therefore you need 4 equations. I have the 4 equations. Now you have to solve the values of A, B, C and D. Okay, you can solve it any way you want. Okay, so for me what I'm going to do is I'm going to say from here that A is equal to minus C. Okay, I'm going to make use of this equation, and also here I'm going to say that D is equal to minus 2B, right? D is equal to minus 2B. I'm going to make use of these two equations over here. So in that case 2A, this equation will become 2A, and B becomes B minus D becomes minus 2B, so it becomes minus B, right? Or let me write this again, my plus B minus 2B is equal to 0, or 2A minus B is equal to 0. This is one equation. Okay, and what about over here? Over here I'm going to say that 2A plus 2B, what is C? C is minus A, right? Minus A is equal to 1, or in other words A plus 2B is equal to 1. Okay, here we already know that B is equal to 2A, right? B is equal to 2A. So therefore I can say that if B is equal to 2A, then I can say that A plus, and 2 into 2 is 4A is equal to 1, or 5A is equal to 1, or A is equal to 1 by 5, which is equal to 0.2. So I found the value of A. So if I know the value of A, then I know the value of C. The value of C is nothing but minus 0.2. Okay, and if I know the value of A, I know that B is equal to 2A. So therefore B is equal to 2A, that means twice this, that is 0.4. And if I know the value of B, then I know the value of D. The value of D is minus 2B, which is nothing but minus 2 into 0.4, which is equal to minus 0.8. So now I found the value of A, B, C and D. Substitute all that over here. So you get, that is S by S square plus 1 into S square plus 2S plus 2 is now it is equal to, what is the value of A? Let me see. The value of A is 0.2. So you have 0.2S, 0.2S, and what is the value of B? The value of B is 0.4. So 0.2S plus 0.4 by S square plus 1 plus, and what about over here? The value of C is minus 0.2. Value of C is minus 0.2. So you have minus 0.2 S plus, and what's the value of D? The value of D is also minus 0.8. This is minus 0.8. Minus 0.8 by, and here you have S square plus 2S plus 1. Okay, very easy, right? So this is also equal to, maybe I can put all this minus outside, right? So it becomes 0.2S plus 0.4 by s square plus 1 minus, here you have 0.2s plus 0.8 by s square plus 2s plus, it's not 1, it is 2, okay, it's 2, right? Okay, so here all I did is I took the minus outside, that's all, okay? So now what I'm going to do is I am going to find the inverse of each of these terms by splitting them, okay? So you all know how to split this, right? This is a very easy equation for you, right? Because we all know that sine Laplace transform of sine omega t is omega by s square plus omega square. All of you know that. Also, the Laplace transform of cos omega t, right? The Laplace transform of cos omega t is nothing but s by s square plus omega square, okay? So using this equation, you have s square plus 1, you can find the Laplace transform by comparing all these equations together. It will be very easy to find the inverse, okay? So this won't be a problem. But what about this one over here? This, you don't know any Laplace transform formulas which is having a denominator looking like this, right? Do you know any? There is no formula in which you know that the Laplace transform formula has having a denominator. There is no formula which is having a denominator that is looking like this. You know that Laplace transform, some formulas of Laplace transform is having a denominator looking like this, but there is no Laplace transform formula which is having a denominator looking like this, right? So what do you do in this kind of a case? In this kind of a situation, what do you do? You see, in that case only, that is where if you see an equation where you cannot factorize, okay? If you see an equation where you cannot factorize, what you can do is you can still do something about this, because you already know that the equation for, let me take for example, the equation for sum of the Laplace transform of a exponential function multiplied with the trigonometric function. For example, e raised to minus 8t, okay, e raised to minus 8t sine omega t. Okay, let's take this for example. We all know that the equation of this one is nothing but omega by s minus a the whole square plus omega square. You see, in this kind of an equation, a denominator where you cannot factorize it, immediately you should understand that you should change this in this form. That's all you need to do. You just think like this. If you see an equation which you cannot factorize, like this one, okay? If you see a non-factorizable equation, all you need to do is simply remember that you can change this in this format. And changing this in this format is a very easy method. It's very easy. And how to change it is, I will show you in a separate step, okay? I will show you how to do this. That is, in this format, just simply look at the denominator over here. It is s square plus 2s plus 2, okay? This is s square plus omega square, okay? See, s square plus omega square, s square plus omega square. So which one of them? That depends on the numerator. But anyway, we know the denominator is s square plus omega square. But here, I want to change it into this denominator, okay? And how to do that is, simply look at this, okay? S square plus 2s plus 2. Now, what you do here is, you simply look at the first two terms. S square plus 2s. Simply look at the first two terms, okay? We all know that a plus b the whole square is nothing but a square plus 2ab plus b square. Yes? A square plus 2ab plus b square. I want you all to simply look at the first two terms. Like I said, simply look at the first two terms, okay? What should be the next value after 2s so that you will get an a plus b the whole square format? Either a plus b to the whole square or a minus b the whole square. If it was s square minus 2s, then it should have been a minus b the whole square. But anyway, s square plus 2s. So what should be the next number after 2s so that you will get this equation? And that value is 1, right? Because s square plus 2s plus 1 is equal to s plus 1 the whole square, right? I repeat, S square. We need to look at the first two terms and try to find the next number so that you will get this form, this formula. What should be the next number after 2s? See, the next number after 2ab is b square, right? Like the same way, what should be the next number after 2s so that a plus b square kind of a format you will get over here. Okay, thus you need an a plus b the whole square format. So in that case, what you do is, we know that s square plus 2s plus 1 is equal to s plus 1 the whole square. So in that case, where does that 1 should come from? S square plus 2s plus 1, right? So where should that 1 come from? That 1 you can take it from here. Okay, so therefore you can rewrite this equation as s square plus 2s plus 1 plus 1. Okay, so what is s square plus 2s plus 1? It is nothing but s plus 1 the whole square plus 1. See, now this equation is in this format. Understood? This is how we do it. So this is actually s plus 1, which means the equation is this one. Okay, e plus okay, this is correct. Actually, it's correct. It is frequency shifting. So e raised minus a is s plus a the whole square. Okay, s plus a the whole square. It's correct early. So this is, see, now this equation is in this format. Okay, see, s plus a the whole square plus omega square. Look at the denominator over here. This is the denominator over here. That is s plus 1 the whole square plus 1. See, now this equation, now you know a lot of Laplace transform formulas whose denominator is looking like this, right? That is this one. You see, if you look at all the denominator of these kinds of formulas, they are always in this kind of a form. That is, either it will be s plus a the whole square plus omega square, or s minus a the whole square plus omega square, or s plus a the whole square minus omega square, or s minus a the whole square minus omega square, right? So in order to have this kind of a denominator, I simply reformulated, or I simply rearranged these terms so that I will get this term. And how did I do that? Is very easy. All you need to do is write the denominator equation over here, and then you simply look at the first two terms. Okay, by looking at the first two terms, you try to find the third term so that you will get this kind of a form. You will get a square equation, that is a plus b the whole square format. Okay, so with that, you know the technique to do that, right? All you need to do is simply divide this, find the next number by dividing this by 2. So you know the next number is 1, so which means it has to be 1 square, or 1 square is nothing but 1 itself. So which means it will become s square plus 2s plus 1, which is s plus 1 the whole square plus 1. Okay, let me take another equation. Okay, let's try another equation just so that you won't get confused. Okay, for example, which equation you want me to try? How about this? How about, let's try this equation: s square plus 4s plus 6. Okay, let's try this equation. S square plus 4s plus 6. What do you do with this when this kind of an equation comes into the picture? How do you, if you're having a denominator that is looking like this, if the denominator is looking like this, what do you do? So it's very easy, right? What you do over here is nothing but you just simply write this in this format, that this will become s square plus 4s plus 4 plus 2. Okay, s square plus 4s plus 4 plus 2. Why? Because this is basically s square plus 4s plus 4 is basically s plus 2 the whole square. S plus 2 the whole square, or this can also be written as s plus 2 the whole square plus root 2 the whole square. See, root 2 the whole square, exactly in this format. S plus a the whole square plus omega square, where omega, the value of omega is root 2, the value of a over here is 2. Here the value of a is 1 and the value of omega square is 1 square. 1 square is 1 itself, right? You see, now you see, this is how we change. That is, all you need to do is simply look at the first two terms, then write the second term, write the next term after this, so that you will get the format of a plus b the whole square, and then subtract that many values from this number over here, and then you'll get this format. Okay, so here that's what I did. Here I know that s square plus 4s plus 4 is s plus 2 the whole square, so I took that 4 from here and write the remaining value. I took the 4 from here, writing the remaining value, I get this s plus 2 the whole square plus 2. Okay, this is how I did. So therefore now I can say that this Laplace transform over here, that is I can say that I of s, okay, let me write I of s. I of s, use this pen. I of s is equal to, so now I can directly write this equation, right? So this is nothing but 0.2s plus 0.4 by s square plus 1 minus, and this is nothing but 0.2s plus 0.8 by, and s square plus 2s plus 2 is nothing but s plus 1 the whole square plus 1 the whole square. Okay, see, very easy. Okay, so now we can simply find the Laplace inverse by separating each and every term. Let me separate the first term. The first term is, you have is 0.2, okay, 0.2 s by s square plus 1. The other term will be 0.4, okay, by s square plus 1 minus, and the other term over here is 0.2 s by s plus 1 the whole square plus 1 the whole square, and the other term is minus 0.8 by s plus 1 the whole square plus 1 the whole square. Okay, so this is, we all know, right, how to write the equations of this. If you are having some kind of a difficulty in writing the equation, all you need to do is simply write the formula separately so that you won't get confused. Okay, I will write the formulas for you in this step. For example, we know here you have s by s square plus 1, right? So we know that the Laplace transform of which one? Sin t, right? Cos t. The Laplace transform of cos t is equal to s by s square plus 1, right? Or if you want, I'll write it over here. I write the whole formula. You can write the formula itself, okay, so that you won't get confusion. So it will be the Laplace transform of cos omega t is s by s square plus omega square. Okay, so you can compare this equation at later stage. Now the Laplace transform of sin omega t, okay, what is the Laplace transform of sin omega t? It is omega by s square plus omega square. Now if you look very carefully over here, the value of numerator is correct, right? S, you simply take 0.2 outside, and here the value of omega is 1. Look at the second term. Second term is, here you have omega by s square plus omega square, right? So what is the value of omega over here? In the denominator, the value of omega is actually 1, right? If the value of omega is 1, then the value of the numerator should also be 1. So you have 0.4 into 1 by s square plus 1, okay? So that won't be a problem. What about over here? We all know that the Laplace transform of e raised to minus at cos omega t, the equation Laplace transform of e raised to minus at cos omega t is nothing but s plus a by s plus a by s plus a the whole square plus omega square. Okay, this is the Laplace transform of this. But if you look over here, this term is missing over here, right? This term is missing. You have an s over here, that won't be a problem, but this term is missing, which means I need to add this term along with this. Okay, that is what it means. I need to add this term along with this. That's the only way I can solve this problem, right? So let's do, what is the value I'm supposed to find? 1. That means I need to add 1 over here. That's what this means. Okay, I need to add 1 over here. So you need to keep that in mind. Now what about the other one? The other one is Laplace transform of e raised to minus at. Here it is omega by rho. So you can write this in this form. This is the equation you need. Sin omega t is equal to omega by s plus a the whole square plus omega square. Okay, so these are the equations you need to understand. So let's do this. So this equation, this won't be a problem, right? I will show it to you why it won't be a problem. That is, I of s can be written as 0.2 into s by s square plus 1. See, so this won't be a problem. This won't be a problem. See, because this is now in this format, right? So this won't be a problem. So the first term won't be a problem. Now let's look at the second term. The second term should be omega. The value of omega is supposed to be 1, right? So therefore we need a 1 at the numerator. But that also won't be a problem, because this can be written as 0.4 into 1 by s square plus 1. See, so that also won't be a problem, because this is basically omega by s square plus omega square, which is exactly what we have here. So that also won't be a problem. Now next let's look at the third term. Like I said, the third term, this a is missing, right? This a is missing. So I need to put an a inside this. So how will I put an a inside this? To put an a inside this, what I need to do is I should take 0.2 outside, or it should be s plus 1. This should be an s plus 1. So which means this should be written like this, right? Which means, let me write this equation in this format. Minus 0.2, okay, minus 0.2. Then what I'm going to do is I'm going to write it plus 1 and minus 1. So 0.2 into s plus 1 minus 1, okay, I'm going to write like this, by s plus 1 the whole square plus 1 square, s plus 1 the whole square plus 1 square, okay. Now what about the other one? The other one also won't be a problem, right? It will be minus 0.8 by s plus 1 the whole square plus 1 the whole square, okay. So still you are not ready to find the Laplace inverse unless you deal this situation only, this third term, right? It's causing a problem for us, right? So that's now what I can do is I'm going to s plus 1, there's s plus 1 over here, so I'm going to take that s plus 1 outside, or I'm going to split this into two factors. One factor having s plus 1, the other one is remaining with minus 1. So therefore this can be written as 0.2 into s by s square plus 1 plus 0.4 into 1 by s square plus 1, okay, minus, now this is going to be written as 0.2 into s plus 1 by s plus 1 the whole square plus 1 the whole square. See, now this is in the format of this form, s plus a by s plus a the whole square plus omega square, right? This is the value of a is 1 and the value of omega is also 1. But now what about the remaining term? There's one remaining term also over here, right? What is the value? It is actually it is minus 0.2, plus point, minus becomes plus. So this becomes plus 0.2. So you have over here as plus 0.2 by s plus 1 the whole square plus 1 the whole square. And what about the remaining answers? Minus 0.8 by s plus 1 the whole square plus 1 the whole square, okay. So now I can combine these two terms, right? Because these two terms have the same denominator, and so therefore I can now add the two numerators also. So it becomes 0.2 into s by s square plus 1 plus 0.4 into 1 by s square plus 1 minus 0.2 into s plus 1 by s plus 1 the whole square plus 1 the whole square, okay. And then over here this can be written as minus 0.2 minus 0.8 is 0.6, so minus 0. So minus 0.6 minus 0.6 into 1 by s plus 1 the whole square plus 1 square, right? Which is basically nothing but this term, omega by s plus a the whole square plus omega square. That is the third term over here. So see, now you can easily write the Laplace inverse, okay. Very easily you can write the Laplace inverse. So you don't have to write this entire step. So I have written all this just so that you can understand why I have to make these corresponding changes in the denominator, because you cannot simply find the Laplace inverse directly from here, right? you cannot find the Laplace transfers directly from here. I have to change this format into this format, right? I hope all of you understood how I changed it by simply changing this format into this format right here by looking at the first two terms and then finding the third term, so that you will get an a plus b the whole square inside this. And that is how I got s plus 2 the whole square. So from there, then I take the remaining term from the other number, so that I'll get s plus 2 the whole square plus 2. Okay, that is in this case. Here it will be s plus 2. So I look at the first two term. So in order to get this number, I need an extra 1 over here. So I'll take that 1 from here. So this will become s square plus 2s plus 1. So you get s plus 1 the whole square plus 1. That is how I got this denominator. Okay, but even then also it's not enough, because the numerator should be changed in such a way that you need an equation that's looking like all of these, right? So that's why I have written all these equations, so that I can now so I can make some necessary combination or necessary changes, so that these equations will be looking like this. Okay, and that is how I did over here. That's how I got this. Now all I need to do is simply apply the Laplace inverse to each and every term, and you got your final answer. So the I of t is equal to nothing but 0.2 into the Laplace inverse of s by s square plus 1 plus 0.4 into the Laplace inverse of 1 by s square plus 1 minus 0.2 into the Laplace inverse of s plus 1 by s plus 1 the whole square plus 1 and minus 0.6 into the Laplace inverse of 1 by s plus 1 the whole square plus 1. Okay, so it's very easy, right? So what is I of t? So what is I of t is, what's the Laplace inverse of s by s square plus 1? Look over here. What is the Laplace transform of s by s square plus 1? It is cos t. So therefore you have 0.2 cos t u of t, that's the first term, plus over here, what is the Laplace inverse of 1 by s square plus 1? The Laplace inverse of 1 by s square plus 1 is sin t. So you have 0.4 sin t into u of t. Okay, into u of t. Then over here minus, now 0.2 into, what is the Laplace transform of s plus 1 by s plus 1 the whole square plus 1? Look over here, the Laplace transform of s plus 1 by s plus 1 the whole square plus 1, it is nothing but e raised to minus t cos t. So therefore minus 0.2 into e raised to minus t cos t into u of t. Okay, you got that, minus 0.6 into, what is the Laplace transform of 1 by s plus 1 the whole square plus 1? What is the Laplace transform of 1 by s plus 1 the whole square plus 1? You get e raised to minus t sin t. So minus 0.6 e raised to minus t sin t into u of t. Okay, into u of t. This is the answer. Maybe if you want, you can now change this in your format, whichever you like to write. Maybe I can write this as, here you can see, if you compare these two equations, I can take 0.2 cos t u of t outside, right? I will get 1 minus e raised to minus t into, this is 0.2 cos t into u of t. Okay, and what about the other one? I'm not so lucky with the other one, right? So other one, even if I can't do anything about that, right? Okay, so in that case, okay, then I'll write, or I can take, I'll just simply take sine u of t outside. Yes, can I do that? I'll take sine u of t outside. So this will become plus, and this will become 0.4 minus 0.6 e raised to minus t. Okay, sine t into u of t. Okay, this is your answer. Okay, So this is how we do the problem. Okay, the reason why I took so much steps is because so much of time is because I have written so many extra steps just so that you can understand how I got these values. Okay, you don't have to write these formulas or anything like that to find it. I wrote this formulas just so that you can understand why I have to change the format of the denominator. Okay, so this is the way the trick is going. That is, you need to, the general summary of this problem is that you need to change these equations in such a way that it should be changed into a format which you can understand. Since you know all the Laplace transform formulas, okay, since you have studied all the Laplace transform formulas, in that case, then all you need to do is change these corresponding equations in such a way that it will turn into a formula which you can understand. And from there, finding the Laplace inverse will become very easy for you. Okay, so this is what we did over here. Okay.